Okay, so I'm going to go over 5.7, number 19. It says form a polynomial f of x with real coefficients having the given degree and zeros. So it's asking us to find a polynomial with degree 4. It's giving us one imaginary 0, and it's giving us a real 0, negative 2 with multiplicity 2. So remember that if it has a complex number like this as a 0, its conjugate is also a 0. So because it's telling us negative 4 plus 5i is a 0, then negative 4 minus 5i is also a 0. So let's start forming our polynomial. So it's going to be x minus, and then the zeros. So x minus negative 4 plus 5i times x minus negative 4 minus 5i times, here we have a real 0, negative 2, so it'll be x plus 2, and then multiplicity 2, so that corresponds to an exponent here. That real 0 is being squared, giving it multiplicity 2. Now it says that our polynomial should have real coefficients, but unfortunately we currently now have imaginary numbers in here. The way we can undo that is to go ahead and multiply out or FOIL out this product right here. I'm going to box it. So we're going to multiply this out. Okay, so let's go ahead and multiply. Change back to red. Okay. So it's going to be FOILed out first, outer, inner, last. So x times x is x squared. Outer will be x times this negative complex number, so minus x times negative 4 minus 5i. Then inner, x times this other complex number, or the negative of it, so negative x times negative 4 plus 5i. And then last, so remember that it's negative times negative, so it'll become positive. And then it's a complex number times its conjugate, and we do have this property of complex numbers and their conjugates. A plus bi times a minus bi is a squared plus b squared. So this will be, a is negative 4, so 16, b is 5, so plus 25. So that's a way you can quickly multiply a complex number by its conjugate. And then we have x plus 2 squared. We can leave that alone. That already has real numbered coefficients. Okay, so the only thing to worry about now is really this terms in the middle. If we did everything right, the imaginary parts should cancel out. So let's go ahead and do some distributing. So I have x squared plus 4x plus 5xi. And then I have here plus 4x minus 5xi plus 25 plus 16 would be 41 times x plus 2 squared. And then we're seeing 5xi minus 5xi cancel. That's great because we want our polynomial to only have real valued coefficients. So combining like terms, we now have x squared plus 8x plus 41. Oops, I put 4i. 41 times x plus 2 squared. So what you have to do is realize that if you have an imaginary 0, like we have over here, then you know that its conjugate is also a 0. Then you have to subtract those from x inside of a factor. That's how zeros work. That has to be multiplied out though, because you want to get rid of the imaginary parts. And if you multiply out everything correctly by FOILing it and distributing, combining like terms, you should be able to get all of the imaginary parts to cancel, and that leaves you with